This is the Artillery Sidewinder X2, which by the way is a 3D printer. Maybe it will help if I keep saying that it's a 3D printer. Anyway, let's have a look at it, shall we? For the first time on this channel, I received this printer to review free of charge from the manufacturer. It's the first time that I haven't actually just bought the printer. I will tell you though that I'm quite happy with the offer to review this printer. Not because obviously I get to play with a printer, but more so because I've been left to review it however I want with no conditions made other than, well, to review it and to link below in the description where to get one, which hopefully I have done. So everything that follows is basically my unedited opinions. I wouldn't have it any other way. So I've got a lot to say, let's crack on. First up, I'll drag you through the build process, and before I get into explaining that, or I guess while I explain it, I will tell you that this printer is an absolute monster in terms of its physical dimensions. By that I mean the footprint, and by that what I mean is the amount of depth specifically that you will need to fit it. I have a film location that fits all my existing printers, but I had some real trouble getting this thing entirely in shot. In fact, I couldn't actually ever at any point get the whole thing in frame. So assembly is really so simple that there's almost nothing to tell you here. The printer is already assembled almost entirely with, I guess you could say it's just two parts that are packed in there separately so that it lies down in the box. The frame, as you can see here, comes out first, and the base is just packed under it. The packaging in printers these days is amazing, I have to say. I mean, it's not biodegradable, which is a bit of a shame. It would be nice to see more biodegradable packaging. Actually, it would be really nice. But it's that weird black foam again, but it's so well formed around the printer that it feels like I'm filming an episode of Mr. Puzzle when I'm taking this thing out. I guess if it cuts down damages in the mail, it's probably something that's important to them. Moving on, something unique to Artillery, I think, is this PCB edge connector that carries everything from the base to the gantry. Old gamers like myself, yeah, I know, it's the same stuff that end connectors from cartridge games used to use. My only hope is that it won't suffer the same corrosion type of fate, but I think it will probably take a while, probably more than the useful life of the printer, but being permanently connected, I'm not that worried about that kind of thing, but just very interesting to think about. Once you've inserted that connector, which you have to do really carefully because the assembly is so huge and heavy, then you've got 4 captive screws in the base to put in, and for your info, it's easier to slide the printer off the edge of the table so it's overhanging and then screw them in from below. I really like that the screws were captive, which meant that this was the easiest way to do it. And they're already installed and they won't fall out because they've got some kind of washer in there that stops them from unscrewing too far and coming out. Especially after the fiasco I had with the G-Tech printer, the last one I built, where I was trying to do this and I lost all of the screws into the body and had to take it apart. I suppose if I wasn't filming the build of this printer, it would have been about 10 minutes. It would have literally have been that quick to build the whole printer and to calibrate it and get it printing. Unusually, even the eccentric nuts on this model were exactly where they need to be, and I am quite surprised by that. The manual does say to adjust them, but I just didn't need to. So for me, the only adjustment that I had to make was to pull this blue bit of plastic outward a bit because it was sort of binding against the belt. But if you get a kind of shushing sound as the hot end moves back and forth, then that will be what's going on. Just kind of ease it away from the belt. Not being an issue since. I can't comment as to whether all units will be this well adjusted, calibrated out of the box. Let's sidestep for a minute though and look at the specs. This printer has a 300mm by 300mm by 400mm build volume, which is a cubic foot but taller, if you want to think about it that way. Or to think about it another way, it's just huge. It's the same size as the other large printers out there like the CR10, which has the same exact volume, probably not a coincidence, and it's pitched at, I guess, around the same price. Similarly, this is also a direct drive printer. We'll have a look at that in a minute. And it's got twin Z screws, which is probably necessary at this size. If you don't have twin Z screws at this size, you are going to have some serious gantry sag. But it has them, so that's fine. We also get auto bed leveling out of the box, and we get this colour touchscreen. Yeah, an actual touchscreen. And it ships with its own proprietary silent motherboard, which we'll have a look at in a minute too. And it has a silent power supply. What do I mean by that? Well, this is one of my favourite features. Listen, do you hear the fans? It's on right now, and it's right behind my head. If you can hear any noise at all, it's probably my PC fan, because the printer itself turns off all the fans when it's on but idle. I know, this does appear like obvious, but printers don't normally do that. This is the future. Printers that don't make noise when they're idle. If anyone knows where I can buy one of these types of PSU for an Ender, then please tell me in the comments, because I need this. So let's have a look at this Hotend then. The design of the filament pushy bit here is what's known as a Titan. It was originally designed by E3d, but this is not made by them. It's essentially a clone. This is a direct drive extruder setup, meaning it's right there on top of the heaty bit there. Why would you choose this instead of an alternative of having a pipey bit between the heaty bit and the pushy bit? Well, direct drives do generally perform better when it comes to retraction. And especially when it comes to squishy stuff like TPU filament. They also seem to cost more. Never quite worked out why. I'm sure there's a reason. The Hotend assembly, though, is a volcano type, which means longer nozzles like this. And yes, I've got some genuine E3d nozzles there for a future video, maybe, or might be able to squish it into the end of this one. And the heat block, this is the reservoir and conductor of heat from the heat element. And this is sideways on compared to usual. This is why the nozzle needs to be longer to fit in there, and it's also because the nozzle needs to be longer, if you get what I mean. It's a chicken and egg situation. Anyway, this causes the nozzle to theoretically perform better because the heat chamber is bigger and there's more contact with the filament as it passes through. So you expect to be able to print faster, at least volumetrically, in theory. The side cooling fan on here exists. It looks like there's been some improvements to the design here compared to the X1. The part cooling fan, though, is slightly more exciting, being fairly large, relatively, and having what looks like a custom-printed nozzle on it. I'll test that out in a bit. Of course, nothing ever happens in a vacuum in 3D printing, and I think there's a good chance that you will know that there were some criticisms of the predecessor to this printer. Every time I talk about these or discuss the internals, I am going to remind you that I am not a qualified engineer, and I do not run an electrical safety test lab. If I say something about the electronics, it is 100% my opinion, and it is not a safety assessment, it is not a safety endorsement. You get the idea. So you know exactly what we need to do now. Oops. The PSU in here is pretty small. And this is because it uses less power than it might, and this is because the bed is actually powered by mains voltage. But there's not an intrinsic reason to worry about that. As you can see, it's... Anyway, never mind that. Look at this. These connections here, this is what I like to see. Let me get one of these out to show you. This is what we call a ferrule. I think they're actually called bootlace ferrules if I remember correctly. I've covered them before, but it bears repeating. Many printer manufacturers are putting tinned solder wires straight into screw terminals, which I thought there was no big deal at first, but as I read more and more about this, these can flex and loosen and basically melt the terminals over time, and you see multiple accounts of people who have burnt boards where these connect into the screw terminals. The solution, or at least one solution, is to use ferrules. So I am very glad to see them here. In fact, the worst problem is actually usually the heated bed terminals, or the incoming supply that then goes out to those heated bed terminals, because they carry a lot more current than any others. That's not even an issue anyway on this board, as I just mentioned, but they've ferruled all the terminals anyway, so what's not to like? The board you see here is the custom Ruby board that this printer comes with. It looks pretty neat to me, and notice the removable drivers, which is something that I like to see, and this is rarely seen on a stock printer control board so far as I'm aware. Usually the drivers are just soldered on, and if you want to replace them you have to buy a new board. Also, I couldn't help noticing that while there's 2 motor driver slots here, and we have 2 motors on this model, they appear to be driving them both off the same chip. While that might seem mad, I did discuss this with some of the members of our Discord. Obligatory, you should join the Discord, by the way, link below as always. The consensus that we came to was that it's easier to keep the Z-axis in sync if you only use one driver. We also did discuss the timing belt that this model has on the Z-axis too, which is an interesting feature, but we couldn't really work out what it's there to solve, if you know what I mean. If you know, tell me in the comments. Speed benchy time? Why not? I thought this wouldn't work. With quoted max speeds for this printer of 150mm per second, I imagined it would be a total mess. But look, it came out okay. It's not the best benchy, it's not the worst. It took 29 minutes though, which is far from a world record, but it's pretty good for this kind of printer. I have seen much worse at lower speeds, so I'm quite happy with that actually. Did exceed my expectations on what a printer with a bed this heavy and a gantry this heavy direct drive is capable of achieving. You can, it seems, as long as you're not worried about neatness, you can print at 150mm per second. It is actually possible. Okay, so it's moan time. This bed is one solid piece of glass. If you're wondering why I'm so intent on not scratching it, then look under it. Nice yellow screws though. Anyway, my point is the bed is just glass with the screws kind of fixed to it. While this does apparently result in a ridiculously flat bed, I'm not sure why, but here's the Octoprint analysis. This is really good. But what are you supposed to do when you actually scratch this beyond all usefulness and want to replace it? My suggestion would be forget about it and put another plate on top. If you put something like a spring steel plate on top of this, you should find that it works well. I set the temperature to 70. I didn't have a spring steel plate for reasons. I tested this by putting your standard Garolite coated ender bed, just plonking it on top, and the plate did reach almost the required temperature in a fairly short time. So I think that's a viable solution, to just put something like spring steel on top and clip it in place with some bulldog clips or whatever you call those things where you come from. So the problem is solvable, but I still feel it would have been preferable to be able to change the glass. I should mention that while I don't have a fancy IR thermal gun like other reviewers do, it is likely, well, it is fact that the design of the bed hasn't changed, and neither will the hot spots that you have seen with the X1 on the bed. I guess I should call them cold spots. I was actually even able to reproduce this pretty easy with a basic IR thermometer. I don't know about you, but this just seems like even more compelling reason to lay a steel bed on top of the glass bed. This will just distribute this heat, and I guess it will make the problem go away. Unfortunately, as I mentioned, I'm not able to directly test this at this time, but I'm fairly confident with it being metal, it will heat fairly uniformly. It will spread that heat out. Really strange design choice, if you ask me. So is there an advantage to the mains bed anyway? Is it quicker to heat up? Let's have a go. That's not bad, especially for a 300mm bed. In fact, that's very good. Since we're doing tests, let's do a sound test next. I have the Ender 3 V2, which is fast becoming one of the most popular printers out there, and it's got silent drivers, but it does not have silent fans, which is a big shame. Here's the Ender when it's preheated to normal values, and here's the X2. Big difference there. Remember, this is a logarithmic scale, and my ears can tell you that this is actually a huge difference. It's the same when printing, not that the Ender makes any servo noise generally, but the fans are intolerable when it's printing. The X2 manages to still make nearly no noise even when printing, and I'm not exaggerating. There's been a few times where I've had to turn around while working literally in front of it because I can't hear it at all, and I'm wondering if it's some kind of malfunction and it's stopped printing. Next up, I tried Octoprint out. Obviously I did, since I showed you a screenshot earlier, so you know I got it working. It works absolutely fine. No plugins, no hacks, everything works as it should. I think that's the first time I've ever added a printer and not had to do anything to make it work. If you aren't using Octoprint on your printer, you need to check it out, especially if your printer has no preheat menu like this one. I'm not sure what this is all about, but there's just no preheat in the menu system. There is an option to preheat when you're changing filament. In fact, the filament change button preheats and then throws it out, which is really cool. I'll show you that now. So, firmware. This printer runs your standard Marlin 2. How do I know? Well, this is a good sign, isn't it? Artillery3d have uploaded the uncompiled firmware to GitHub, and I can confirm while some choices are suspect, namely 270 degrees C as a maximum temperature for PTFE lined Hotend max temp is not ideal, but the safety features in Marlin all seem to be enabled, which is something I would expect, but I checked it anyway. For the record, a metal Hotend does exist for this printer. You can buy it as an optional extra, so I guess that might explain the former point. Now, being a Volcano-style Hotend and a big printer, one of the things I wanted to do was swap out the nozzle to a 0.6 or 0.8, and I have, as you saw earlier, got the nozzles from E3D to do that. This will not only enable you to print faster, because that's what happens when you put bigger nozzles on, and the reason I'm going to be doing this later is because I'm going to be revisiting the wide vase mode, which I've done before, and there were some unresolved issues and suggestions at the end of that video. Before we do wind up, I want to show you some of the test prints I've done very quickly because of the amount of time that this review has already taken. I try to generally print things that I need, if possible, to save on waste, especially if I'm doing larger tests. So here's a really cool box from my WoW stick. This came out really well. I recommend it. To test the first layer and calibration, I printed a couple of these kit cards to assemble, and they came out perfect, no curling or warping. I also tested for Z banding, as Angus had noticed it, but I'm not seeing it on my printer. I mean, maybe I am. It doesn't seem like it's any worse than any other printer. This headphone stand is one I've been waiting to print for a while. I had one before, I gave it to someone, and I never got round to printing a replacement for myself. This fits with room to spare on this bed, a lot of room to spare. Okay, this video is way longer than I normally like videos to be, so I suppose I should come to some conclusions then. Should we do pros and cons? If you insist. The main pros that I would consider worth picking up this printer for would be the bed size, the auto bed leveling that works out of the box, how quiet it is, the quick bed heat time, and the apparent reliability that I've had in terms of bed adhesion. I've had zero issues with bed adhesion, surprisingly for glass. So in terms of cons, well, the big one is the choice of the non-removable glass plate, which I have mentioned at length. The cold spot issues that come with that just make that even worse. Otherwise, the lack of simple preheat in the firmware, ironically there's a cool down but no preheat, that would be a simple firmware fix, and it would be nice if they would implement that. I don't think it would be too hard. And the filament holder, I didn't have time or the inclination to show you the filament holder because it's just a filament holder, which is something that you can easily replace. It works, and that is literally all I have to say about it. I suppose we can moan about it all day long, but in its defense, it has bearings in it, and so it doesn't make those creaky, groany noises that we're used to, but enough about that. Well, what do you think? Comment below and tell me. I guess the first takeaway that I have, if I'm not overstepping by pointing this out, is that Artillery appear, at least as far as I can tell, to have resolved all the serious concerns of the previous model's reviews. So we have to kind of give credit for that. So if you're looking to prioritise size, silence, quality of life functions like auto bed leveling and filament sensing, over the inconvenience and thermal situation of the bed, then this is probably the printer for you. Thank you for watching if you still are here. Next time I'm going to be looking into something top secret. I don't want any of the other big 3D printer channels to steal my idea, and I'm sure they all watch my content. So you'll have to wait and see. I will see you next time.